Hi everyone, this is Mrs. Latham. Today we will be looking at section 3.7, and this section is actually broken up into two lessons. So we will be looking at the first lesson, which is absolute value equations. For today, you're going to need a notebook and a pencil to take notes, and your learning objective is that students will be able to find the absolute value of any number, and students will be able to solve an equation with absolute value. So let's get started. The absolute value of a real number x, written as the absolute value of x, is the number's distance from 0 on the number line. So what does that mean? When we're looking at the numbers here, we want to see how far they are from 0. So if I start with my -3 on my line, it is 1, 2, 3 spots, but to the left of 0. So the absolute value of -3 is 3. Same goes for the positive version of 3, right? So positive 3 is going to be 1, 2, 3 values to the right of 0. So notice in this case, right, the numbers are positive when we take the absolute value, and in this case, they're going to be the same for the numbers. If we were looking at the absolute value of -5, that would be 5. If we looked at the absolute value of 2, that would be 2. So, knowing that information, we can actually solve equations with absolute value. The first step is to isolate the absolute value expression, meaning that we should only be left with whatever is inside those two lines. Then we're going to write an equivalent pair of linear equations. So, looking at that first problem on the left here, I'm going to zoom in actually. We have the absolute value of x plus 2 is equal to 9. So notice that the absolute value of x is not isolated. There is a plus 2. So we have to move the 2. In order to do that, I'm going to draw my line. I am going to subtract 2. Oops, sorry guys. I don't know what just happened. Let's zoom back in. We are going to subtract 2 on both sides. The 2's on the left cancel. We are left with the absolute value of x, and then it's going to equal 7. Now, the second step is to write equivalent pairs. So what that means is we are going to write two equations, one for positive 7 and one for negative 7. Because if you think about it, right, 7 and -7 are the same distance away from 0. So we have to look at the positive and the negative. So when we do that, my first equation is just going to be x is equal to 7. Notice we don't actually have to solve anymore. We already have one of our answers. And then the second one here is going to be x is equal to -7. So if I plugged in 7 back in for x, or -7, back in for x, we should get 9. So just to quickly show you, I am going to substitute back in. So for here, the absolute value of 7 plus 2, well, that gives us 7 plus 2, which is 9. If I do it with my -7, I get the absolute value of -7 plus 2, which again is still 7 plus 2, which gives us 9. So we know that we solved for these correctly. Now let's look at the second example. Here, we are multiplying -3 by the absolute value of x. So to undo that, we need to divide by 3, -3. When we divide by -3 on both sides, the -3's on the left cancel, the absolute value of x comes down, and then -12 divided by -3 gives us a positive 4. My first equation is going to be x is equal to 4. And then the second one is going to be x is equal to -4. Again, we can actually plug in to make sure it works, so I will do that for this one as well. -3 times the absolute value of 4 is equal to -3 times 4, which is -12. Then I can do the same thing for -4. So we have -3 times the absolute value of -4, which is 3. -3 times 4, which is again -12. So our answers work. So that's what happens when we're just left with x on the inside of the absolute value, but sometimes we're not. If we are solving an equation in the form of the absolute value of a, where a is your variable expression, is equal to b has to be greater than 0. B can also equal 0 as well, but most of the time we're going to be looking at b is greater than 0. We are going to solve for a equals b, and then a is equal to negative b. So what we were just kind of practicing before. Looking at that first one here, notice my expression is already isolated. So I don't have to change anything. I'm just going to solve for the two equations. So again, my first equation here is going to be 2x minus 5 is equal to 13. That's where b is positive. But then my second equation is going to be where b is negative. So I'm going to have 2x minus 5 is equal to a negative 13. Draw my lines to solve. First step for both of these is to add 5. On the left, we're going to get 2x is equal to 18. When I go to do it on the other side, we're going to get that 2x is equal to negative 8. Then on both of them, we're going to divide by 2. On the left side, we get x is equal to 9. And then on the right side, we are going to get that x is equal to negative 4. So notice in this case, unlike the other two, the values that we get are not like the opposites of each other. Like before, we were getting positive 7, negative 7. Here, we're getting two completely different numbers. They're not even opposites. We have 9 and negative 4. Now, if you're kind of curious, do these work? You can go back in and check. So 9 times 2 gives us 18. 18 minus 5 gives us 13. Absolute value of 13 is 13, so we're good. Then 2 times negative 4 is negative 8. Negative 8 minus 5 is negative 13, but the absolute value of negative 13 is positive 13. So we are all set. For the second one, notice here now we have our absolute value expression, but there's things on either side. So we will have to remove some things before we write our equation. This is a step that a lot of students forget. The 3 that's being multiplied and the negative 3 both have to be removed before we write our two equations. So I'm going to add 3 first. 3 on the left cancels out. I'm left with 3 times the absolute value of 2x plus 9, and that is equal to 15. Then I have to go ahead and divide everything by 3. 3's on the left will cancel, and we're left with the absolute value of 2x plus 9 is equal to 5. Since 5 is greater than 0, we can write our two equations. So again, the first one is going to be 2x plus 9 is equal to 5, just like how it looks. And then the second one is going to be 2x plus 9 is equal to our negative 5. Then I'm going to draw my line to solve each of them. Okay, for both of these, we are going to subtract 9. On the left-hand side, 9's cancel, bring down the 2x. 5 minus 9 gives us negative 4. On the right-hand side, 9's cancel, and 2x is equal to negative 14. Last step for both of these is to divide by 2. 2's will cancel out on both of them, and I get that x is equal to negative 2, and x is equal to negative 7. So that is our two answers. And again, you can go back in and check. And I would always recommend starting with that first one that we were given. So 2 times negative 2 is negative 4. Negative 4 plus 9 gives us a positive 5. 5 times 3 is 15. 15 minus 3 gives us 12. So the first equation's all set. Now, negative 7 times 2 gives us negative 14. Negative 14 plus 9 is negative 5. absolute value of negative 5 is 5, times 3 is 15, minus 3 is 12. So we are all set for that. Okay. As for the last two, we have to remember that absolute value is representing the distance from 0 on the number line. Therefore, the equations have to state that the absolute value is positive and not negative. If it does say that b is negative, then it's going to have no solution. So looking at that first one, we have our variable expression, right, which is the absolute value of x minus 7. That's our a. But then look at what we're given here. We're given negative 5. That's our b value. Well, b in this case is less than 0. It is not greater than 0. So this is a no solution. We cannot solve this. Distance is always positive, not negative. And this is saying we have a distance of negative 5. Not possible. Okay? For the second one here, sometimes, right, if we're looking here, the 2 is positive. So right now it looks like b is a positive number. We should be able to write two equations, but that might not be the case. If I were to add 7 to both sides, 7's cancel, and I get negative 3 times the absolute value of 2x plus 9 is equal to 9. And you're like, oh, well, 9's still positive. We should be able to solve. But we have to isolate our variable expression. So I still have to divide by negative 3. And what ends up happening is when I divide by my negative 3, I get the absolute value of 2x plus 9 is now equal to negative 3. So notice, right, our b value is less than 0. It is not greater than 0. So we cannot solve this now. This is also a no solution. So we have to be very careful when we're isolating the variable expression because we might end up getting a no solution and might not notice. Okay? That is it for this lesson on absolute value equations. Next time I see you guys, we'll be working on absolute value inequalities. Have a great rest of your day. Bye, guys.